Greetings, everyone. Today we're going to continue to explore writing linear equation word problems. Now think of this as a second part of the video series, so if you're just starting, please check out my first video. Just a quick little review of what was discussed before or in class is talking about how in the real world we don't say slope. We talk about a rate or a change, and some keywords we look for are words like per and each that help us identify what that change is. And B, you hear me say in class all the time that that's the beginning, which works out in the real world. Where are we beginning our count from, beginning our change from? Now, what if I don't know the beginning, right? I still have my rate, but what if I have a point in time? Meaning, if I have, let's say in 5 months, I have $50. That's a point in time. And so a point in time, we would have to use point slope form. So your input versus your output number. All right, so a couple of steps. You probably already have these in your notes, but things you need to think about and recognize in our scenarios is what is your input? Don't forget it's typically time. If there's a time element, that's almost always your X input. What your output is depends on the scenario, right? Are we talking weight? Are we talking money? Are we talking height? We need to figure out which number represents the slope or the change. Look out for those keywords. And then where are we starting from? Is it a beginning or a point in time? All right, so take a look to see if you have these notes to fill in. Otherwise, you can certainly jot them down. But let's work through these word problems in a more basic way. If you have this text in front of you, one of the things I recommend is kind of dissecting or marking the text down. All right, so a car is traveling on a straight road. Let's say like to Fargo, right? At 8 a.m., the car is located 20 miles from the starting point. By 10 a.m., the car has traveled 50 miles from the starting point. Assume the car travels at a constant speed. Keeping it very generic for the sake of simplicity. We want to write an equation that models the car's distance from the starting point as a function of time. This is unique. This didn't happen in our first video. In our first video, we had 2 numbers or we had 3 numbers. But now I have 4 numbers. Maybe make a note of that. If I have 2 points, right? I'm saying at 8 a.m., 20 miles away. And then at 10 a.m., 50 miles away. That's 2 points in time. If I have 2 points in time, let's back out of the idea of a word problem. We're writing an equation given 2 points. See my previous videos for that, but I'm going to zoom through here. First thing, the only thing we've been finding with 2 sets of points is the slope. So if I calculate, I arrive at 15. There's my m value. And so I'm going to write point slope form. Pick your point. Any point is fine. And let's write point slope form. Again, I'm zooming through this part because you can see my other video if you still need help with this. There's my equation. I don't need to solve for y because it doesn't say to. It says write the equation. Equation is written. Question, how far will the car be from the starting point at 12 p.m.? Meaning if my x is 12, what's my y, right? If I know my time. And so I'm going to take my equation, but wherever there's an x, I'm going to fill in that value of 12. So now this is just a calculating and a solving problem. We've got 12 minus 8, which is 4. 4 times 15, which is 60. So all of this became 60. And if I add 20 over, I have 80. But 80 what? How far will the car be? The car will be 80 miles, right? Reread the question to know your label. We're 80 miles away from the starting point. Let's take a look at another one. A factory produces widgets. At 9 a.m., we've got 300. At 2 p.m., 950. Let's stop for a second. How many numbers did I just read? 1, 2, 3, 4 numbers. If it's 4 numbers, that can be written as 2 points. So let's talk about those 2 points. At 9 a.m., 300. At 2 a.m., 2 p.m. Let's back up there. I can't write a 2 because that would mean 2 a.m. So what do I write instead of 2 p.m.? I write 14. Think of a clock, right? 12 o'clock, 1 o'clock would be 13, 2 o'clock would be 14. So pay attention to that, highlight that if you need to. There's our 2 points. Let's go through all the algebra work we have previously done. When given 2 points, you want to find the slope. We could have crazy slopes as well. I won't give you anything too nuts, but it's real world. Real world's not always clean cut. If we divide, nice, perfect 130. That is my slope, my m. So let's write our equation. Pick any point you want. I'm just going to pick the first one because it's first. Y minus 300. 130 is my m. X minus 9. Again, see other videos if you need help with that process, because that should be fast by now. Now, I didn't even read the question. Write the equation of a line that models. Perfect. There's my equation. Let's use the equation to find out how many have been produced by 4 p.m. Well, wait a second. We can't just plug in 4 because that would look like 4 a.m. So think of your clock. 4 o'clock would be, that's right, 16. Our x, our input, our time is 16. So if I take my equation and instead of x, I'm going to fill in 16. All right, let's calculate. We have 16 minus 9, which is 7. We want to take 7 times 130, which is 910. And then to solve for y, we're going to add 300 over. So we're at 1,210. Well, let's fully answer the question. How many widgets will the factory have produced by 4 p.m.? 1,000 widgets. Use the same vocabulary. Now let's see if that makes sense. I'm going to just temporarily jump back up here to my points. So I'm saying at hour 16, I'm at 1,110. Does that make sense? As time went on, did we make more? Yes, that makes sense with the scenario. All right, let's try another one. A jogger starts to run at 7 a.m. and has run 2 miles. The jogger runs at a constant rate of 5 miles per hour. Let's mark this up. A rate means that 5 is my m. Up here, it sounds like I have a point in time at 7 a.m., 2 miles. Time, miles. Write an equation that models the total distance the jogger has run as a function of time. If I have 3 numbers, a point, and a slope, then I have point, slope, form. Slope always goes in front of x, and let's fill in our point. There's my equation. Done. Question: how far will the jogger have run by 9:30? Okay, well that's a time. That's a time. Does time go in for x or for y? It's my input. That's my x number. So I'm going to start by writing my equation again. But instead of x, wait, do I write 9.3? 9.3? No, I want to think of it as 9.5. So when I fill that in, I'm actually going to write 9.5. Okay, so be careful. If it's a half hour, that's half an hour, so 0.5. Alrighty, let's solve and see if we made sense. 9.5, and we're subtracting 7. We're timesing that by 5, and we're adding 2. I'm not going to show my work, but please do so in your notes. So let's reread the question. How far will the jogger have run? 14.5 miles. Is it okay to have a decimal? Yeah, because we're talking miles. I could have any kind of decimal for miles. And this makes sense. Okay? Let's see if this, let me write it out. At 7, we're at 2 miles. And now we're saying at 9:30, we're at 14 miles. Does that make sense? Sure does. All right, let's take a look at this one. A small business starts with $4,000 in its bank account at the beginning of the year. At the beginning. It's literally telling us the beginning. Every month, the business earns every means this is my slope, $500 in revenue. If I know my beginning and I know my M, that's an easy problem. Fill in our slope, fill in our beginning. Revenue means positive, making money, so it's a positive slope. All right, how much total revenue will the business have after 8 months? 8 months is time, time is X. So let's rewrite our equation, but where there's an X, we're going to fill in an 8. Oh, this is straight calculator work, right? 500 times 8 plus 4,000 is 8,000. 8,000 what? It says how much revenue, $8,000 would be my revenue, which makes sense. All right, last one here. A car rental company starts with 50 cars in its fleet. The company rents out 3 cars per day. All right, sounds like this is at the beginning of the day. And per means this is my rate. Write an equation that models the number of cars remaining in the fleet. Oh, so what kind of 3? The 50 is decreasing by 3. So that's a negative slope. So when I go to fill in my equation, make sure I have a negative 3 because I'm decreasing from my positive 50. All right, let's fill this in. How many cars will be left after 12 days? 12 is time, time is X. So in my equation, let's change that X to 12. Let's calculate. Negative 3 times 12 would get me negative 36. 50 and negative 36 leaves me with 14. 14 what? 14 cars if you read the question. So this video really shows you how you will be assessed on these problems in the sense of I'm not telling you what kind of equation, how to write the equation. It's just write the equation and use it. You have to understand the rest. So consider if you are writing a lot to go and re-listen to some of these problems. Make sure to ask questions. Check out Google Classroom to see what your task is. And until next time, have a good one.